Hello everyone, welcome to the course Computer Networks. This is S. Parvathi, Assistant Professor, Department of CSIT, MLR Institute of Technology. In today's session, we are going to discussing about Bluetooth and Ethernet in data link layer. Let us see the first overview of today's topic. In today's session, we are going to discussing about first what is Bluetooth, and next we are going to discussing about what is the blue snarfing in Bluetooth, and next we have to discuss about what is Bluetooth protocol stack in Bluetooth. We have to discuss in today's session, and next we are going to discussing about what is Ethernet, and next we have to discuss about Ethernet frame format in Ethernet. Let us see the first what is Bluetooth. Bluetooth is nothing but, first of all, where exactly we are using Bluetooth. What is Bluetooth? Bluetooth is a wireless technology. It is a wireless technology standard. Mainly it is used for what purpose? For data exchanging in between the fixed and mobile devices over a short distance. Means for short distance range, we have to share the data. Means we have to exchange the data in between the devices over a short range. We are going to use the Bluetooth. So this Bluetooth using the short wavelength, ultra high frequency radio waves we are going to use for sending the data in between sender and receiver in the ISM radio bands. ISM is nothing but industrial, scientific and medical frequency. Using this, we are going to send the data from the range is 2.400 to 2.485 gigahertz, and building the personal area networks we are going to use means personal area network means what? Within the room only we are going to use, means here we are going to use for what purpose? For short distance, means for sending the data in between, for exchanging the data in between the devices over a short range. That is the personal area networks we are going to use the Bluetooth. It is the technology for it is a wireless technology. So it is originally conceived as a wireless. It is an alternative to the RS-232 cable. Previously we discussed in guided transmission media, unguided transmission media, right? In that we discussed what is RS-232 cable. There we are going to use this Bluetooth concept. So this Bluetooth is a wireless technology. It is named after the Harald Bluetooth. It is based on analogy that the Bluetooth technology would united devices. That way Harald Bluetooth united the tribes of the Denmark into the single kingdom. That is the Bluetooth. And next, this Bluetooth, how it is going to be exactly work. So it is specified by as an industry consortium. It is called as the Bluetooth Special Interest Group, that is ISIG, Special Interest Group. So it specifies the entire suite of protocols. It is going to beyond the link layer to define the application protocols, which it calls as a profile. Means we already discussed OSI is having the 7 layers, like so. This Bluetooth comes under which layer? Data link layer, right? Data link layer. What it is going to say about? It is going to behind the data link layer only. To define the application layer protocols, we are going to use the data link layer. So which it calls as a profiles for a range of applications. There is a profile for synchronizing a PDA, that is personal digital assistance, with a personal computer. It can be used in the personal digital computers. Okay, that is a PDA. Another profile, see, one profile is talking about the PDA, that is a personal computer, and another profile also gives the mobile computer that access to the wired LAN. It is access to the, this is for mobile computer, personal computer, and it is for wired LAN, that is the mobile computer. So the basic Bluetooth network configuration is called as a Piconet. Mainly it is talking about the Piconet. The Bluetooth network configuration is exactly called as a Piconet. What is Piconet exactly? What it contains? These are the contents in the Piconet. See, it consists of the master device. First, it will consist master device and up to 7 slave devices. Means, see this picture. This is the Piconet and scatternet. So it is having the, suppose this is the diagram. Here this is the master. It is the master node, and it is having the exactly 7 slaves. Only it is having exactly, we can, means more than 7 it will not accept, but less than 7 it will accept. Means 4, 2, 3, 4, 5 like this it is accept, but more than 7 it won't accept. Means one Piconet is nothing but it is equal to the 7 slaves. Means each master is having 7 slaves. Means less than 7 also it will be acceptable. See this picture, see in this, it is consisting of the master device. Up to 7 layers is going to be having 7 slave devices is going to be have. That is the Piconet. That is the first condition. Any communication is between the master and the slave. Means this is the master node. to this master node. Slaves are connected to this particular master node. This is the master. These are the slave nodes. These are the slave nodes. All are connected to the master only. The communication, any communication is going to be there in between the master and slave. That may be wired communication or wireless communication. The slaves do not communicate directly. Means here the communication is in between master and slave only. There is no communication in between the slaves. There is no direct communication in between slaves. And next one, a slave can be parked. That is, its set is an inactive. That is, if it is inactive, that is low power state. Means if the slave is inactive, that means it is having the low power state. These are the conditions of the piconet. Then it is called as a piconet. Then what about the scatternet? Scatternet is nothing but the combination of piconets is nothing but the scatternet. So this is one piconet. Another one is also there. This is the master. Here also number of slaves, means near to 7 is acceptable, right? This is the slave. This is also slave. Here are the slaves. These are the 5 slaves. These all are connected to this particular master. This is the one piconet. This connection in between these two is nothing but the combination of the piconets is nothing but the scatternet. That is about the Bluetooth. So in this, what are the devices is going to be there here? See, these are all. This is a master node. This is a master. These are all consist of the slave nodes. These are all called as the slave nodes. All are connected to this particular master node only. There is a communication in between master and slave. There is no communication in between the slaves. That is the condition of the piconet. So, what are the main advantages of this Bluetooth is? It is low cost, at the same time easy to use. It is easy to use. It can also penetrate through walls also. And it creates an ad hoc connection. It creates one ad hoc connection immediately without any wires. Means for sending the data using the Bluetooth, there is no wires are required for sending the data. Right? That is, without any wires, we can send the data using a ad hoc connection. It is used for the voice and data transfer. By using these Bluetooth, we can transfer the voice as well as the data also. Example, Bluetooth speakers and headsets are the examples for the Bluetooth. Every day in real time, we are going to use Bluetooth speakers and etc. These are the examples for the Bluetooth. So, what are the main disadvantages of this Bluetooth is? It can be hacked. Maybe there may be chance of the hacking also and less secure also using the Bluetooth. So, it has slow data transfer rate. So, whenever we are transferring the data in between the devices using the Bluetooth, there is a slow data transfer. That is the disadvantage. It has small range. The range means when we can use this Bluetooth connection means the range is only 10 meters. Means that sender and receiver distance only 10 meters means that is the personal area network. Then only it will be applicable for sending the data. This is the disadvantage of the Bluetooth. And what is blue snarfing here? Blue snarfing is nothing but it is an unauthorized access. It is mainly unauthorized access is nothing but there is no trustworthy. It is not a trustworthy. There is no trustworthy. That is nothing but the unauthorized access of the information from wireless device. It is a wireless device through the Bluetooth connection, often between the phones, desktop, laptop, PDA, anything. We are connecting through the Bluetooth. It is a unauthorized access. So, like it as a theft. It is a Bluetooth theft. That is a blue snarfing. This allows access to the calendars, contact list. Means if using Bluetooth, if it is going to be hacked, it access the calendars, contact list, emails, text messages, and some more phone information. Users can copy the pictures and private videos from our phone also. That is nothing but this is nothing but Bluetooth snapping. That is blue snarfing. Blue snarfing is the theft. It is a theft information from the target device. Suppose one target device, this is a target device. If you want to access some information from this particular phone using this blue snarfing is nothing but we are going to access unauthorized access. That is the unauthorized access. That is nothing but blue snarfing. And next one is what is Bluetooth protocol stack? Means how it is going to be sending the data between sender to the receiver. These are the Bluetooth protocol stack is going to be there. See in this here this is the diagram for the Bluetooth protocol stack. See this is having the physical layer, data link layer, middleware layer and the application layer. These are the layers it is going to be deal. And next what is first of all what is physical radio layer? That is this is physical radio layer. What is this one? It is mainly talking about the modulation and demodulation of the data. Whatever data is going to be there, that is going to be modulated and demodulated into the RF signals, that is radio frequency signals. That is the physical radio layer, and it defines the physical characteristics of the Bluetooth. Means it is having the transceiver, means it is as a transmitter, at the same time receiver, means transmission and receiving is going using these RF signals. It defines the two types of the physical links. Means RF layer is having the two links, that is connectionless as well as the connection oriented links. That may be connection link as well as the connection oriented link in the RF layer. This is the first one, physical radio layer. And the next one is what? Baseband layer. What is baseband link layer here? It performs the connection establishment. Mainly it is talking about the connection establishment within the piconet. Already we said piconet is nothing but what? Here is the master is there. Here this master is connected with the slaves. These are the slaves. This is called as the what? It is called as this. It is called as this total is called as what? Piconet. So the connection establishment within the piconet only we are going to connect the devices. That is nothing but the baseband link layer. For that work we are going to use this baseband link layer. And next one is the link manager protocol layer. This is the link manager protocol layer. What it is going to be do? It performs the management of the already established links. If we are going to manage whenever we are sending the data, for that purpose we are going to managing the already existing links. We are going to use establishing links. We are using link manager protocol layer. And it also includes the authentication and encryption process. Means encryption, authentication means trustworthy information purpose. We are going to use the link manager protocol layer. And logical link control and adoption protocol layer. So here it is there, logical link control and adoption protocol link layer. What is the main aim of this? It is also known as the heart of the Bluetooth protocol stack. Mainly it is saying that it is the heart of the Bluetooth protocol stack. Why it is called as the heart of the Bluetooth protocol stack? We will see. It allows the communication between the upper and lower layer. Mainly for communication in between the upper and lower layer of the Bluetooth, and it packages the data packets received from the upper layers and into form of the expected by the lower layers. And it also performs what it is performing? Segmentation and multiplexing. Multiplexing means what? Combining all signals into one signal for sending the data. Segmentation is nothing but for one signal we are going to divide into another signal. We are doing it, performing the segmentation as well as the multiplexing. All comes under the logical link control and adoption protocol layer. And next one, so next one till here we completed, right? Next one is what? RF communication layer. What is RF communication layer? RF is nothing but radio frequency. It is a short for radio front end component. It is for what? Radio front end component. This is the radio front end component. Mainly it providing what? It is going to providing the interface with WAP and OBEX. What is it? It is an interface in between WAP and OBEX. What is WAP and OBEX? WAP is nothing but the wireless application protocol. Means it is a wireless application protocol. OBEX is nothing but object exchange. Means RF communication layer in between the interface, like I say, in between WAP and OBEX. WAP is talking about the wireless application protocol. It is nothing but OBEX is nothing but object exchange. It is an interface between both WAP and OBEX, that is RF communication layer. And next one is what? TCS. And next, see what is TCS? TCS is nothing but telephony. See, it is a short form of telephony is called as a TCS. It is a telephony control protocol. It mainly providing the telephony services. We are going to use the TCS. And next one is service discovery layer. That is nothing but SDP layer. SDP layer is mainly talking about service discovery protocol. Mainly, what is it going to be talking about? It discovers the services. Service discovery means discover the services available on the Bluetooth, another Bluetooth enabled device. What are the services available on the another Bluetooth device? We are going to tell in the SDP layer. And next one is what? Application layer. What is application layer here? Application layer mainly for enables the user to interact with the application. Means user, means here is the interaction in between the applications. We are going enables the user. We are going to use the application layer. This is about the protocol stack of the Bluetooth. See, audio and control also used. Audio for voice and control is for controlling the data. This is the application layer. This is the application. This is about the Bluetooth protocol stack. And next one is what? Ethernet. What is Ethernet? Ethernet is nothing but it is the one of the most widely used wide LAN technology, that is wide local area network technology. This is the Ethernet is a wide technology, wide LAN technology. It operates in the data link layer. Mainly it is operates in the data link layer and the physical layer. In between data link and physical layer, we are going to use the Ethernet, that is the wide. At the same time, the family of these networking technologies that are going to be defined in mainly where we are going to use the Ethernet is IEEE 802.2 and IEEE 802.3 standards. We are going to use the Ethernet. So, what exactly it is supporting the bandwidth is 10, 100, 1000, 10,000, 40,000 Mbps, like means 100 Gbps till 100 Gbps it is going to be support. That is the Ethernet. So, what are the different Ethernet standards are going to be there? See here, it is defining the layer 2 protocols. Mainly Ethernet is talking about what? Layer 2 protocols and layer 1 technologies. And two separate sublayers are there in the data link layer. What are the two sublayers? LLC, logical link control layer, and MAC sublayer is going to be there. These two are going to be deal in the Ethernet. So, how the Ethernet is going to be evolution, how the evolution is going on the Ethernet is, first one is the standard Ethernet and second one is the fast Ethernet and gigabit Ethernet, and next one is the 10 gigabit Ethernet. These are the evolutions of the Ethernet evolutions. See, standard Ethernet is having the speed is 10 Mbps and fast Ethernet having the speed is 100 Mbps and gigabit Ethernet is having the speed is 1 Gbps, gigabits per the second. 10 gigabit Ethernet speed is having the 10 gigabits per the second speed is having. These are the evolutions of the Ethernet evolutions. Means we are going to use based on the sending the data, based on sending the data, how fast we have to send the data, based on that we are going to selecting the Ethernet connections. That is the Ethernet evolutions. And next one, how the Ethernet format is going to be happen. See, this is the diagram for the Ethernet frame format. See here it is having the first one is the preamble and next SFD. SFD is nothing but the start frame delimiter. And next one is the destination address, source address is there, length or type is there, data and padding is there, and CRC is there. This is the frame format of the Ethernet. See, preamble it is having the 7 bytes and next SFD is talking about the 1 byte and next destination is allocated for 6 bytes. Here source is 6 bytes and length is 2 bytes and next data, whatever data is we are receiving in the form of frames only, right? That is the data only. CRC for error correction and detection, that is for 4 bytes. So, preamble is mainly having how many bits? 56 bits. 56 bits altering ones and zeros. Only it is having the ones and zeros. SFD mainly for start frame delimiter. Means it is having the flag. This is the flag. Like that it is going to be there. So, preamble and SFD is called as the physical layer header. This is the Ethernet frame format. At the same time, here preamble for the starting address, starting of the Ethernet. At the same time, it is a start frame delimiter. It is having the destination address where we have to send the data. Source is talking about the address of the sender address. And length is talking about the what is the exact length, that is the payload field, also called as the capacity also. What is the exact capacity? And it is the data. It is the CRC, cyclic redundancy check. It is talking about the error correction and detection. This is the frame format. And next one is Ethernet frame minimum and maximum length. What is the minimum and maximum length? Here is the destination. Already we know it is having 6 bytes. Sources address, it is also 6 bytes. Length, PDU is having the 2 bytes only. And data, whatever data we are sending from the sender to the receiver, that data, cyclic redundancy check, correction and detection of the errors. That is 4 bytes. This is okay. What is the length we are talking? So, minimum payload length. What is the capacity? That is the 46 bytes. Minimum is 46 bytes. Maximum payload length is what? 1500 bytes. That is the payload length. And next one, minimum frame length. This is the payload length. This is the frame length. Frame length is, minimum frame length is 512 bits or 64 bytes. And maximum frame length is 12,144 bits or 18 bytes. That is about the frame length. This is the payload length. This is the frame length. This is the minimum and maximum length of the payload and frame length. This is about all about the Ethernet frame format. And next one in this Ethernet frame format, frame length. Already we discussed minimum is 64 bytes, maximum is 1500 bytes. that is 512 bits, 12,144 bits. So, how we are going to give the Ethernet address to exactly for that particular device? How we are giving the Ethernet address? This Ethernet address is nothing but what? MAC address, Medium Access Controller Address. So, this is the example how exactly address is going to be given to particular device. Means suppose this device is there. We are giving some MAC address to particular device. This is the MAC address of the particular device. How we are allocating the address is, this is the address, right? Total it is having the 6 bytes. 1, 2, 3, 4, 5, 6. These are the 6 bytes of the address. Each is having the 12 hexadecimal digits. Means total how much it is having? 48. How it is 48? Means total is 6 bytes. 6 into 8. Total is having the 8. Total is what? 48 bits. 1 byte is having how many bits? 8 bits. So 6 bytes. 1 byte is 8 bits. Total is 48 bits. That is the MAC address. This is the MAC address. So the least significant bit of the first byte, it defines to the type of the address. Whatever the least significant bit, that is going to be talking about the type of the address. Which type of it is going to be address. And if the bit is going to be 0, means if the bit is going to be 0, the address is unicast. Means whatever bit, if the bit is going to be 0, that is the unicast. Otherwise, it is multicast. Means if the first byte of the bit, that is if it is 0, then it is a unicast. If this is the first byte, in that first byte, if the first bit is going to be 0, then it is called as a unicast. If it is otherwise, it is the multicast. If all ones are there, if the first byte is this one only, if all ones are going to be there, then it is called as a broadcast address. If it is 0, unicast. If it is 1 of the first byte, then that is called as a what? Multicast address. If all bits are going to be in the first byte is all ones, then it is called as the broadcast address. These are the different bytes. Total how many bytes is it is having? 6 bytes, right? Total 6 bytes. Bits coming to bits, it is 48 bits. We are talking only about the first byte. First bit, if it is 0, then it is a unicast. First bit, it is in the first byte. In the first bit, if it is 1, it is a multicast. If all ones are there in the total byte, then it is called as the broadcast address in the Ethernet frame format. So, this is about the Ethernet address. So, coming to the summary, today we discussed first of all what is Bluetooth, and next we discussed what is blue snapping, and next we discussed what is Bluetooth protocol stack in Bluetooth, and next we discussed what is Ethernet, and next we discussed what is the Ethernet frame format in data link. These topics we discussed in today's session. Thank you.